everyone. In this video, let us discuss about text wrangling. So just we are going to look like how to use Python for text wrangling. So in all the machine learning models, we used to pre-process the data, right? So similar to that, even in NLP, it is really required to do text pre-processing, right? So let us try to understand that in detail, right? So what are the pre-processing steps, or what kind of wrangling we can do with the text data, right? So let us start it. So first I have imported NLTK. From NLTK, I have downloaded Punch, WordNet, stopwords, average perceptron tagger, right? Okay. So I have taken an example of text. Machine learning algorithms can help in converting text to numeric feature vectors, right? So when I execute this code, I'm getting the same output because basically I'm trying to get the output of text. So when I write dot lower, so let me clear all this output now, right? So that would be really interesting, I guess. So let me clear the output. So this is basically the text. So what I'm doing now is text dot lower. So what I'm getting now, you can see that in the previous line, you can see capital M, right? Machine learning algorithm. So that is converted into lowercase. Now, when I write text dot upper, I can convert everything into uppercase letter. Text dot title, right? Text dot title. So what I'm getting, machine learning algorithms can help in converting text to numeric feature vectors. So what is the difference here? Capital M, capital L, capital A, capital C, capital H. That is what happening because we have given title, right? So this is basically about the case conversion, right? So the next one is about tokenization. What do we do in tokenization? Let us see. So this is basically the sample text I have taken. Text processing, text pre-processing is a crucial step in NLP. Cleaning our text data in order to convert it into a presentable form that is analyzable and predictable for our task is known as text pre-processing, right? So import NLTK, NLTK dot send underscore tokenize sample text. So what is happening here? The first sentence is text pre-processing is a crucial step in NLP. And the second sentence is that cleaning our text data in order to convert it into a present form that is analyzable and predictable for our task is known as text pre-processing, right? So if I want to convert it into a word tokenization, now you can see that text is separate, pre-processing is another word, is another word, is another word, crucial is another word. So these are basically the tokens, right? Now I have used NLTK dot talk tokenizer, and just let me do that. Now again, what you can see is text pre-processing is a crucial step, right? So this is what we are getting. So now I have imported Spacey, and from Spacey, I'm loading encode web SM. So what is that? So after that, what I'm doing is text underscore Spacey is equal to NLP sample text, right? So what is the sample text over here? Sample text is this one, right? So after that, what I'm doing, obj dot text for obj in text underscore Spacey dot sense, right? So now in the next step, what I'm doing, text underscore Spacey, right? So I hope this is clear, right? So this is what happening over here. The same thing we have done with the help of Spacey, right? So in case if I want to remove HTML tags and noise, so I have imported request and request dot get, and just I have written one URL dot text, right? So the next step, what I have done is, in the next step, what I have done is I have imported RE from BS4 import beautiful soup, define strip underscore HTML underscore tags text. So soup is equal to, this is what I have written the code. Now let us execute and see what is happening over here, right? So you can see that this is basically the this is basically present in that particular URL, and this is what I'm getting. So this is the start of the Project Gutenberg ebook, the Bible King James Book 1, right? So this ebook was provided by David Whitger, right? So this is what I'm getting, book 01 Genesis, right? So now if I want to remove accented characters, I'm importing Unicode data. So define remove underscore accented underscore chars text. Text is equal to Unicode data dot normalize nfkd dot comma text dot encode ASCII that I'm asking to ignore, and decode UTF-8 ignore, right? So let me execute this code. And for example, I have taken I have assigned some accented text to A, and let me execute this. Now you can see that this is basically accented text, right? So now in case if I want to remove this accented characters, just I'm writing remove underscore accented underscore chars, right? So what is happening now? I'm getting the output as some accented text only, right? So import RE, define remove underscore special underscore characters, text comma remove underscore digit equal to false. So basically I'm making remove underscore digits equal to false, and then I'm writing pattern also. If not, remove digits, else this one, right? And I'm asking it to subtract sub that pattern comma text, right? So when I do that, so I'm taking a sentence over here. Well, this was fun. See you at 7:30. What do you think, right? So now in case if I want to remove all these special characters, remove underscore special underscore characters from this, yes, basically remove underscore digits equal to true. So now you can see that I'm getting only the text, I'm getting only the string, I'm not getting any special characters over here. So when I write remove underscore special underscore characters, now I'm getting the digits also. In the previous case, I have written remove underscore digits is equal to true. So I asked it to remove the digits, right? So that's the reason the digits was being removed, right? So hope it is clear, right? So this is what being done by these things. And then let us try to understand Porter stemmer. From nltk.stem, import Porter stemmer. So ps is equal to Porter stemmer and ps.stem. I have given some examples like leaving, leaves, left. So you can see that ps.stem leaving, then ps.stem leaves, ps.stem left. So what is happening now? I'm getting output as LEAV, LEAV, LEFT. So what does this stemmer do? This provides the, or this cuts this word, and it is just reducing, I mean, it is just eliminating this ing and just giving me the output. So here the problem is LEAV doesn't have any meaning, right? So in case if I write LYING, I'm getting LIE, right? This is fine. When I write for strange, I'm getting STRANG, which doesn't carry any meaning. Sometimes what may happen is when we do stemming, it may lead us to, it may give us some word that actually has some other meaning. So those are the complications with the stemming. Now import NLTK, PS equal to NLTK.Porter stemmer, NLTK.stem.Lancaster stemmer that I have written in LS, and define simple underscore stemming, text comma stemmer equal to PS, and then just I have written this function, right? So when I run this and I have taken, my system keeps crashing from yesterday, okay, yesterday, or crashes, okay. Presumably, we are not lying, right? Okay, so let me run this now. What I'm writing now, simple underscore stemming, yes, comma, stemmer equal to PS. My system keeps has changed into keep, crashing has changed to crash, from yesterday, presume, we are not lying, right? We are not lying. So that has changed to we are not lying. So now simple underscore stemming, yes, comma, stemmer equal to LS. Now what is happening? My system keep crash from yesterday. So I think I'm getting the same other than this one, right? R is changed to AR. In case if I use limitization, what will happen? So in limitization, it will take the root word which have the proper meaning. So from nltk.stem, import wordnet limitizer, WNL equal to wordnet limitizer, and help WNL dot limitize. So now you can see that what is happening here. Say for example, cars. Right now, car is changed to car. And when I try to limitize this boxes, I got the output as box. For running, I'm getting run. Ate, eat. This is brilliant, right? Because this is not possible with stemming. Ate is converted into eat. Then with the adjectives, saddest is changed to sad, fancier is changed to fancy. So the next one is about ineffective limitization. You can see that 8, fancier, fancier, and fancier, fancier, right? What is over here? Like what I'm trying to say is like here I'm specifying that which whether it is a noun or verb, just I have mentioned over here. Now I'm taking another, usually we use this example in all the documents. Yes is equal to, the brown foxes are quick and they are jumping over the sleeping lazy dogs. It looks funny. I'm going to tokenize it now. When I tokenize it, it is getting converted into tokens, which means the words. Now I'm going to limitize that. So what is happening now? The brown fox are quick and they are jumping over the sleeping lazy dog. Now I'm using the POS tag. What I'm getting the corresponding tag for each and everything. Say for example, sleeping means sleep plus ing. Basically it is verb plus gerund, right? So this is what I'm getting. Even for jumping, we are getting the same, right? So this is what we are getting. From nltk.corpus, import wordnet.add, right? So I am getting A, right? So define POS underscore tag underscore wordnet. And for this tagged tokens, I'm doing, right? So when I do that, I'm getting for each and every case. What is this basically, right? We know what is what, right? So what is happening here? It is tagging with the POS, right? So you can see here, for verb, it is being written as B, and for adjective, it is being J, and adverb, noun. So everything is being denoted already here under this tag underscore map, right? So what are we getting now? I'm getting what I'm getting yan basically, right? So that is what I'm getting. Sleeping is basically verb. Lazy is basically adjective, right? So this is what actually happening, right? Sorry, adverb. Lazy is basically what is that? Lazy. Where is that? It is showing it as A, right? So we know that, right? Okay, fine. So the next one is about limitized text. And here we are, for each and word tokens, we are doing it. When we do that, we get the brown facts. You can see that here, WNL dot limitize word comma tag for word comma tag in wordnet underscore token. So what is happening here? The brown fox are, right? So the R is converted into B. Quick and they are get converted into B. Jumping got converted into jump over the sleep lazy dog, right? So hope it is clear, right? So you can also try out something like this. Then WNL is equal to wordnet limitizer, and and here again I'm giving the limitizer now. So the same sentence, if I try to limitize underscore text of X, this is what I'm getting, right? The same thing, right? Fine. So this is what I am getting, right? Now the next one is that define remove underscore stop words. Text is underscore lower underscore case is equal to false. Stop words is equal to none, right? If there are no stop words in the sense here I have used English, right? If it is lowercase, what has to be done? Otherwise, what has to be done, right? So when I run this, then we write nltk dot corpus dot words English, right? So this is being I, me, my, myself, we, our, ours, ourselves, you, you are, right? So it is showing some stop words, okay? And then in case if I ask it to remove the stop word, now what I can see, previously it was the brown foxes, right? So the is missing, the is removed, brown foxes, or right, R is being removed because it is a stop word. Quick jumping. So over is basically a stop word that is being removed. Sleeping lazy dogs, right? So you can also try out that. So in case if you want to remove something specifically, you can do that, right? So stop underscore words dot remove the, stop underscore words dot append brown. And in case if you want to remove underscore stop words, yes, the lowercase equal to false and stop words equal to stop underscore words. So what is happening now? Since I have asked this to do it, I'm getting the foxes quick jumping the sleeping lazy dogs, right? So hope this is clear to you. So this is a simple notebook which is clearly explaining about text wrangling. Let us meet in the next session. Thank you.